What's going on, guys? Britta here, back with the Odin Project, and we are on alignment in the Flexbox. So far, everything we've touched with Flexbox has used the rule flex 1 on all flex items, which makes the items grow or shrink equally to fill all of the available space. Very often, however, this is not the desired effect. Flex is also very useful for arranging items that have a specific size. This section contains a general overview of topics that you will learn in this lesson. You'll learn how to align items inside a flex container both vertically and horizontally. Let's look at an example. You should be able to predict what happens if you put flex 1 on the dot item by now. Give it a shot before we move on. So dot item, we're going to put flex 1. So that stretched it across the width. Adding flex 1 to item makes each of the items grow to fill the available space. But what if we wanted them to stay the same width but distribute themselves differently inside the container? We can do this. Remove flex 1 and add justify content space between. So justify content space between whoops, I put it on the wrong thing. So let's delete that. And it said add it to the container. Okay, that looks nice. Doing so should give you something like this. Justify content aligns items across the main axis. There are a few values that you can use here. You'll learn the rest of them in the reading assignments, but for now, try changing it to center, which should center the boxes along the main axis. So if we change this to center, there we go. To change the placement of items along the cross-axis, use align items. Try getting the boxes to the center of the container by adding align items center to the container. So let's remove this. Align items. What did it say? Center? Yeah. So that moved all of it down. The desired result looks like this. However, it's not in the middle. Maybe I should have left. I didn't say to remove it, so I think that's why it looks funky. Justify content center. There we go. Now it looks right. Because justify content and align items are based on the main and cross axis of your content, their behavior changes when you change the flex direction of a flex container. For example, when you change flex direction to column, justify content aligns vertically and align items aligns horizontally. The most common behavior, however, is the default, i.e. justify content aligns items horizontally because the main axis defaults to horizontal, and align items aligns them vertically. One of the biggest sticking points that beginners have with Flexbox is confusion when this behavior changes. Gap. One more very useful feature of Flex is the gap property. Setting gap on a Flex container simply adds a specified space between Flex items, very similar to adding a margin to the items themselves. Gap is a new property, so it doesn't show up in many resources yet, but it works reliably in all modern browsers, so it is safe to use and very handy. Adding gap 8 pixels to the centered example above produces the result below. There's more for you to learn in the reading below, but at this point, surely you can see how immensely useful Flexbox is. Using just the properties we've already covered, you could already put together some impressive layouts. Take your time going through the reading. There will be some review of the items we've already covered here, but it goes into more depth and touches on a few things that haven't been mentioned yet. Don't stress too much about trying to memorize every little detail yet. Just code along with the examples and do your best to internalize everything that is possible with Flexbox. You'll have to reach for these resources again once you get to the practice exercises, but that's perfectly acceptable. The more you use this stuff, the better it will stick in your mind, and you will be using it constantly. Have fun. Alright, so we're going to read this, the basic concepts of Flexbox. The Flexbox module, usually referred to as Flexbox, was designed as a one-dimensional layout model and as a method that could offer space distribution between items in an interface and powerful alignment capabilities. This article gives an outline of the main features of Flexbox, which we will be exploring in more detail in the rest of these guides. When we describe Flexbox as being one-dimensional, we are describing the fact that Flexbox deals with layout in one dimension at a time, either as a row or a column. This can be contrasted with the two-dimensional model of CSS grid layout, which controls columns and rows together. The two axes of Flexbox. When working with Flexbox, you need to think in terms of two axes, the main axis and the cross axis. The main axis is defined by the flex direction property, and the cross axis runs perpendicular to it. Everything we do with Flexbox refers back to these axes, so it's worth understanding how they work from the outset. The main axis is defined by flex direction, which has four possible values: row, row reverse, column, column reverse. Should you choose row or row reverse, your main axis will run along the row in the inline direction. Choose column or column reverse, and your main axis will run from top of the page to the bottom in the block direction. The cross axis runs perpendicular to the main axis. Therefore, if your flex direction main axis is set to row or row reverse, the cross axis runs down the columns. If your main axis is column or column reverse, then the cross axis runs along the rows. Start and end lines. Another vital area of understanding is how Flexbox makes no assumption about the writing mode of the document. In the past, CSS was heavily weighted towards horizontal and left to right writing modes. Modern layout methods encompass the range of writing modes, and so we no longer assume that a line of text will start at the top left of a document and run towards the right-hand side, with new lines appearing one under the other. You can read more about the relationship between Flexbox and the writing mode specification in a later article. However, the following description should help explain why we do not talk about left and right and top and bottom when we describe the direction that our flex items flow in. If the flex direction is row and I am working in English, then the start edge of the main axis will be on the left and the end edge on the right. If I were to work in Arabic, then the start edge of my main axis would be on the right and the end edge on the left. In both cases, the start edge of the cross axis is at the top of the flex container and the end edge at the bottom, as both languages have a horizontal writing mode. After a while, thinking about start and end rather than left and right becomes natural and will be useful to you when dealing with other layout methods such as CSS grid layout, which follow the same patterns. The flex container, an area of a document laid out using Flexbox, is called a flex container. To create a flex container, we set the value of the area's container display property to flex or inline flex. As soon as we do this, the direct children of that container become flex items. As with all properties in CSS, some initial values are defined, so when creating a flex container, all of the contained flex items will behave in the following way. Items displayed in a row, the flex direction property's default is row. The items start from the start edge of the main axis. The items do not stretch on the main dimension, but can shrink. The items will stretch to fill the size of the cross axis. The flex basis property is set to auto. The flex wrap property is set to no wrap. The results of this is that your items will all line up in a row using the size of the content as their size in the main axis. If there are more items that can fit in the container, they will not wrap but will instead overflow. If some items are taller than others, all items will stretch along the cross axis to fill its full size. You can see in the live example below how this looks. Try editing the items or adding additional items in order to test the initial behavior of Flexbox. So div 1, 2, 3. 3 has extra text. Let's add this doesn't work the way that I thought it was going to. I can't tab over, so let's add a div 4. Changing flex direction. Adding the flex direction property to the flex container allows us to change the direction in which our flex items display. Setting flex direction row reverse will keep the items displaying along the row, however the start and end lines are switched. If we change flex direction to column, the main axis switches and our items now display in a column. Set column reverse and start the end, and the start and end lines are again switched. The live example below has flex direction set to row reverse. Try the other values, row, column, and column reverse to see what happens to the content. So flex direction, we're going to try row reversed, and then we're going to do column reverse. 3, 2, 1. Multi-line flex containers with flex wrap. While Flexbox is a one-dimensional model, it is possible to cause our flex items to wrap onto multiple lines. In doing so, you should consider each line as a new flex container. Any space distribution will happen across that line, without reference to the lines on either side. To cause wrapping behavior, add the property FlexWrap with a value of wrap. Now, should your items be too large to display in one line, they will wrap onto another line. The live sample below contains items that have been given a width, the total width of the items being too wide for the flex container. As flex wrap is set to wrap, the items wrap. Set it to no wrap, which is also the initial value. So we'll do no wrap. Using no wrap would cause an overflow if the items were not able to shrink or could not shrink small enough to fit. The flex flow shorthand. You can combine the two properties, flex direction and flex wrap, into the flex flow shorthand. The first value specified is flex direction and the second value is flex wrap. In the live example below, try changing the first value to one of the allowable values for flex direction, row reverse, column reverse, and also change the second to wrap, no wrap. So row, no wrap, and we'll change this to flex, display flex, flex direction, row. Let's try column. That didn't do anything. Let's try column reverse. Display flex. Try changing the first value. Oh, I think we have to change this. Display flex. Flex flow, row, no wrap. Flex direction, row. Flex direction, flex column. Properties applied to flex items. To have more control over flex items, we can target them directly. We do this by way of 3 properties: flex grow, flex shrink, flex basis. We will take a brief look at these properties in this overview, and you can gain a fuller understanding in the guide, Controlling Ratios of Flex Items on the Main Axis. Before we can make sense of these properties, we need to consider the concept of available space. What we are doing when we change the value of these flex properties is to change the way that available space is distributed amongst our items. This concept of available space is also important when we come to look at aligning items. If we have 3 100 pixel wide items in a container which is 500 pixels wide, then the space we need to lay out our items is 300 pixels. This leaves 200 pixels of available space. If we don't change the initial value, then Flexbox will put that space after the last item, which looks silly. If we instead would like the items to grow and fill the space, then we need to have a method of distributing the leftover space between the items. This is what the flex properties that we apply to the items themselves will do. The flex basis property. Flex basis is what defines the size of that item in terms of the space it leaves as available space. The initial value of this property is auto. In this case, the browser looks to see if the items have a size. In the example above, all of the items have a width of 100 pixels, and so this is used as the flex basis. If the items don't have a size, then the content size is used as the flex basis. This is why when we just declare display flex on the parent to create flex items, the items all move into a row and take only as much space as they need to display their contents. The flex grow property. With the flex grow property set to a positive integer, flex items can grow along the main axis from their flex basis. This will cause the item to stretch and take up any available space on that axis, or a proportion of the available space if other items are allowed to grow too. If we gave all our items in the example above a flex grow value of 1, then the available space in the flex container would be equally shared between our items and they would stretch to fill the container on the main axis. The flex grow property can be used to distribute space in proportion. If we give our first item a flex grow value of 2 and the other items a value of 1 each, 2 parts of the available space will be given to the first item, 100 pixels out of the 200 pixels in the case of the example above, 1 part each, the other 2. The flex shrink property. Where the flex grow property deals with adding space on the main axis, the flex shrink property controls how it is taken away. If we do not have enough space in the container to lay out our items and flex shrink is set to positive integer, then the item can become smaller than the flex basis. As with flex grow, different values can be assigned in order to cause one item to shrink faster than others. An item with a higher value set for the flex shrink will shrink faster than its sibling and have lower values. The minimum size of the item will be taken into account while working out the actual amount of shrinkage that will happen, which means that flex shrink has the potential to appear less consistent than flex grow in behavior. We'll therefore take a more detailed look at how this algorithm works in the article Controlling Ratios of Items Along the Main Axis. Shorthand values for the flex properties. You will very rarely see the flex grow, flex shrink, and flex basis properties used individually. Instead, they are combined into the flex shorthand. The flex shorthand allows you to set the 3 values in this order: flex grow, flex shrink, flex basis. The live example below allows you to test out the different values of the flex shorthand. Remember that the first value is flex grow. Giving this a positive value means the item can grow. The second is flex shrink. With a positive value, the items can shrink, but only if their total values overflow the main axis. The final value is flex basis. This is the value the items are using as their base value to grow and shrink from. Giving this a positive value. Okay. There are also some predefined shorthand values which cover most of the use cases. You will often see these values used in tutorials, and in many cases these are all you will need to use. The predefined values are as follows: initial, auto, none, and a positive number. Setting flex initial resets the item to the initial values of Flexbox. This is the same as flex 01 auto. In this case, the value of flex grow is 0, so items will not grow larger than their flex basis size. The value of flex shrink is 1, so items can shrink if they need to rather than overflowing. The value of flex basis is auto. Items will either use any size set on the item in the main dimension, or they will get their size from the content size. Using flex auto is the same as using flex 11 auto. Everything is as with flex initial, but in this case the items can grow and fill the container as well as shrink if required. Using flex none will create fully inflexible flex items. It is as if you wrote flex 00 auto. The items cannot grow or shrink, but will be laid out using Flexbox with flex basis of auto. The shorthand you often see in tutorials is flex 1 or flex 2 and so on. This is as if you use flex 110 or flex 210 and so on respectively. The items can grow and shrink from a flex basis of 0. Try these shorthand values in the live example below. So flex 1, let's try flex 2. What if we do them all at 2? Flex 1, flex 2. What if we do flex 1, 1, 0? It's the same thing. We do flex 2, 1, 0. Alignment, justification, and distribution of free space between items. The key feature of Flexbox is the ability to align and justify items on the main and cross axes, and to distribute space between flex items. Note that these properties are to be set on the flex container, not on the items themselves. Align items. The align items property will align the items on the cross axis. The initial value for this property is stretch, and this is why flex items stretch to the height of the flex container by default. This might be dictated by the height of the tallest item in the container or by a size set on the flex container itself. You could instead set align items to flex start in order to make the items line up at the start of the flex container. flex end to align them to the end, or center to align them in the center. Try this in the live example. I have given the flex container a height in order that you can see how the items can be moved around inside the container. See what happens if you set the value of align items to stretch, flex start, flex end, center. So if we set the value of align items, so align items, that's flex start. Let's do flex end. Stretch. And center. The justify content property is used to align the items on the main axis. The direction in which the flex direction has set the flow. The initial value is flex start, which will line the items up at the start edge of the container, but you could also set the value to flex end to line them up at the end, or center to line them up in the center. You can also use the value space between to take all the spare space after the items have been laid out and share it out evenly between the items so that there will be an equal amount of space between each item. To cause an equal amount of space on the right and left of each item, use the value space around with space around items have a half size space on either end. Or to cause items to have equal space around them, use the value space evenly. With space evenly, items have a full size space on either end. Try the following values of justify content in the live example. So that's flex start. Flex end should move them all the way to the right. Center should center them. Center did not center them. Oh wait, we gotta take out the flex. Just center. Okay, it did center them. Now let's do space around. Okay. Space between. Space evenly. Nice. Alright, in the article, Aligning Items in a Flex Container, we'll explore these properties in more depth in order to have a better understanding of how they work. These simple examples, however, will be useful in the majority of use cases. The Justify Items property is ignored in Flexbox layouts. Okay, so that's that, and then we have Aligning Items in a Flex Container. Let's just take a peek at that. I'm not going to read the whole thing, but this is more practice, and these diagrams are super helpful. Typical use cases of Flexbox is another article. I'm not going to read the whole thing, but again, it looks super helpful, and I encourage you guys to do that, to read this, and I'm going to read it off camera. And then we have CSS Tricks Guide to Flexbox. There's a whole poster. I want that poster. I'm going to download that. This actually looks really useful. So I encourage you guys to read that. And I will as well. And then it looks like we have some exercises, but we're going to go ahead and start working on those exercises in the next video. And so I will see you guys there. Bye.